And in this video, we're going to look at 6.10. So in 6.10, we know that inverse functions we have exponential and logarithmic functions are inverses. So that means when you take this purple graph and fold it across y equals x, because that means we're switching the x and the y, then you get the orange graph. And the orange one is the inverse. Okay? So remember that the inverse function swap the x and the y, which means you are changing the domain and the range. Your domain and range will switch. So look at this graphing example. So we have f of x equals log of 4 minus x. So we have that graphed, and you can use Desmos. Okay, you guys know how to use Desmos, so you can type that into Desmos, and you're going to see this red graph right here. So determine the x and the y intercepts. Okay, so the x and the y intercepts, click on the x and y intercepts, and that's going to give you those 2 points. So we know the x-intercept is at 3, 0, so that's your x-intercept. And we know that this right here is 0.602 is going to be your y-intercept. Okay, so that's your y-intercept. All right, so then find the domain and the range of the vertical asymptote. So you're going to do is solve the inequality for h of x minus h is greater than 0. Okay, that's this part right here, the 4 minus x. So take that 4 minus x, set it greater than 0, and solve. So you're going to get x's are greater than 4. Okay, so that's for your domain. Your domain is all x's greater than 4. All right, so then for your vertical asymptote, you're going to take that x minus h, that part inside the parentheses, and you're going to set it equal to 0, so you get x equals 4. Okay, so that means the line, let me get rid of some of that, so the line x equals 4, and I'm kind of drawing it dotted, is your asymptote. Okay, that means it's a line that it gets really close to, that red line right there, that red graph right there. The log of 4 minus x gets really close to x equals 4, but it never touches it. Okay, it gets really close to it, but it's never going to touch it. That's the definition of an asymptote. Okay, and our domain is all x's less than that. So that's where we get x is less than 4. And your vertical asymptote is x equals 4. All right, so then we have this graph. It would be a good idea if you save this somewhere. Okay, so you have all of the different translations. Okay, all the different translations. You can move it up and down, left and right. You can vertically stretch it. That means if you multiply by a number greater than 1, or if you multiply, you will have a vertical compression if it's between 0 and 1, which means it's a fraction, like 1/2. Okay? Now you can have a horizontal compression if you multiply the x inside the parentheses by a number greater than 1. Okay, that means it's going to compress by a factor of 1 over a. Make sure you use this table right here. It tells you exactly how to word it. Okay, now you can also horizontally stretch it by a factor of a. If you multiply by a fraction on the x, that means you're going to stretch it by a factor of 1 over a. All right, so now here's an example. How does the graph of log base 3 of x minus 2, then plus 1 at the end, compare to its parent function of log base 3 of x? All right, so let's look at what it's doing. We're subtracting 2 from the x, okay? So look down here. That means it moves right 2. Okay, look down here at your table. You can see if you're subtracting a number from the x, it moves right, that number of units. And then, if you're adding something at the very end, it moves up, 1 unit. So this thing is being shifted right 2 and up 1. So let's see, right 2 up 1. So looks like it's C. Okay, so right 2 and up 1. All right, so now let's look at some practice questions. This one is just like number 1 on your 6.10 quiz. So graph the following Desmos. So graph it in Desmos. Take note of all the important information. Okay, so you need to graph it. Make sure you understand how to put this in Desmos, like the x-intercept, the y-intercept, the way it curves, and all that kind of good stuff. And to put this into Desmos, you can use, now you got to click on the little function at the bottom, miscellaneous, and you can use the log base A right there to type it in. Now, this one will have an asymptote of x equals 0. Look at that. This one's going to have an asymptote of x equals 0. That tells me the domain is all x's greater than 0. Okay, because all x is going to the right, all of them greater than 0. You do not have an x-intercept, so you have none for the x-intercept. And then for the y-intercept, it is at 9, 0. Okay, and then you see how it curves upward. Okay, so question number 1 is going to ask you something along those lines, so make sure you use Desmos. All right, on question number 2, what is the domain of the following function? Okay, so in the domain, take this x minus 2, set it greater than 0. Okay, so set it greater than 0 and solve. So in this case, you get all x's greater than 2. So on your quiz, very, very important, just put the number in the box. Just put the number in the box. So it's going to ask you all numbers greater than blank. You just put the number 2. Do not put x is greater than 2. Just put the number 2, or just put the number of whatever you get in the box. Okay? All right, so on question 3, very similar, except you are finding the vertical asymptote. So take that stuff inside the parentheses, set it equal to 0. So in this case, you're going to take the x plus 1, set it equal to 0, and you get x is equal to negative 1. That means your vertical asymptote is at x is equal to negative 1. So again, on your quiz, just put the number. Don't put x equals negative 1, just put the number. Okay, just the number. All right, on question 4, how does the graph of f of x equals log base 3 of x minus 3 minus 4 compare to its parent function of log base 3 of x? All right, so we have this x plus 3 right here. So look down here at your table. When you're adding a number to the x, it goes left. So left looks like 3. And then if you're subtracting a number at the end, it looks like it goes down. So this one is going down 4. Okay, so we need to choose the answer that says left 3, down 4. So shifted 3 units to the left and 4 units down. So it looks like it's A. All right, so let's look at an example like number 5. Given the parent function, f of x equals log base 4 of x, find the equation of the graph below. So gather what you know. Plug it into Desmos if you don't have the graph right there. Okay, vertical asymptote is at x equals negative 3. You have 2 points. Okay, you're probably going to be given 2 points. Plug in for h. Okay, now we know that this thing is, the parent function is log base 4 of x. This thing moved to the left 4. Okay, that thing moved to the left 4. And it looks like it went down. It went down. How many do you think it went down? Looks like it went down 2, because typically this point is up here. Okay, So, and if you don't know that, plug the log base 4 of x into Desmos. Okay, plug it into Desmos, and you'll see how to, and you'll see where it goes. So you're going to see that it moves down 2. Okay, so that means you're going to take that function and write it as if it goes left 4, down 2. Or sorry, it's 3. Oh my goodness, look, your asymptote is -3. It's left 3. Left 3. So it goes left 3, down 2. Okay, so that means you're going to add 3 to the x, and you're going to subtract 2 at the end. Okay? And you can always plug a point in and make sure it works.